talk is the Future is Reactive talk. Now, if you hear about how to get from imperative to reactive, that is next in this room. This is reactive for beginners. If you've never done anything with reactive programming, I'm gonna try my best to explain what it is and how you can get into it. And hopefully in the next session, you'll learn how to actually take your application from imperative to reactive. So my name is Cecili Reid. This is actually my third time speaking here at Devnexus. One thing that you will learn about me, or if you've seen me speak before, is I like audience involvement. I don't like to just stand up here and drone on without getting to know my audience and who you are. So I am using Slido. There's a QR code up here, but you can also go to slido.com on your cell phones, on your laptop. I have a poll up there to get a sense of your comfort level with reactive programming. I will also have Q&A through Slido as well because I hate to be interrupted. I have practiced this talk, I have a nice groove going, and if you have questions, it's gonna throw me off. So I am being as helpful as I can be. Every slide is numbered, so if you ever have a question in the presentation, just note the slide and ask it in Slido right then and there. And in fact, I think it's a better experience because right when you have the question, you can just ask it rather than at the end try and remember what it was you wanted to ask in the first place. So while everyone comes in and bring up Slido and answer the poll, I'll tell you a little bit more about myself. My name is Cecili Reid. I'm a senior software engineer at Netflix. I've been there for about 1.5 years on their content acquisition and finance engineering team. Basically, that means I build a bunch of accounting software for production accountants, tracking budget, cash flow, all of that stuff for Netflix productions. Before Netflix, I was at MailChimp as a full stack engineer, and then I was also at NCR, and before that, I was a contractor. I got my CS degree from Georgia Tech, and I am also a LinkedIn Learning instructor. I have 3 courses on LinkedIn Learning right now around Java and Spring, and I have a 4th coming out this fall. A disclaimer in the big red letters there. I am not here speaking on behalf of Netflix. In fact, they probably don't even know that I'm speaking today. My coworkers do know I'm attending the conference and that I am speaking, but this presentation has nothing to do with Netflix. I say that to say, please don't ask me anything about Netflix. No, I don't know when the next season of whatever comes out. I do know, but I'm not gonna tell you that. So with that said, hopefully you see the Slido down at the bottom for any new people who have come in. There's a poll up there as well as that's where you can answer Q&A. All right, let's see what the poll results are. Oh, come on, Slido, don't do this to me. I had everything ready and up, and then Slido decides to just shut down on me. Sweet. There we go. Perfect. I was going to be worried if anyone said that they were an expert and was in this room. I am definitely aiming for the people who say reactive what, beginner, novice. This presentation is for you because if you are an expert, you should be here and not me. This presentation is for you. I'm not an expert in reactive. I just struggled to learn it myself, and I just figured there will be other people in the same boat as me, and I wanted to share that. All right, let's go back to the presentation. Perfect. So if you're like me, when you see code like this, I don't know what the heck is going on. I actually wrote this last night because I couldn't find a good nonsense reactive programming example. My goal was to try and throw in as many reactive buzzwords and operators and things as possible and to make it look as convoluted as possible. Don't worry. We're not really going to go through every line of this. Like I said, it does nothing important. But this is how I felt when I saw some reactive code. Like, what is this that I'm looking at? I don't understand any of these terms. Flux sounds like it's a made-up word out of Harry Potter. They probably do have some kind of flux there. And I realized that I was avoiding reactive programming because I just didn't understand it. I thought I hated it. I still kind of do, but I wanted to understand reactive programming so I understood why I hated it and what the benefits were to it. So one of my coworkers, who I consider to be a reactive expert, we were having one of these discussions about how much I hate reactive programming, and I just didn't understand the point of it. And he pointed me to the Reactive Manifesto at reactivemanifesto.org. And this talks about 4 key components of reactive systems. And it's something that I reluctantly read, but I read it anyway. The first thing to know about reactive systems are that they are responsive. They are high quality applications that respond to all of the issues and problems and make sure that your users have high confidence in your system. They are resilient, where if failures do happen, you're able to recover from them, and those failures are compartmentalized to the point that it's not going to affect your entire system. They are elastic, meaning your resources scale. And the last thing, the thing that was important to me, is they are message-driven. This message-driven principle hints to asynchronous and non-blocking messaging. Basically, that's what reactive programming is. It's all about asynchronous communication, non-blocking messaging, where you don't want to block the thread that you're currently in to do a piece of work. And the main focus is routing and consumption of events. So I realized this routing and consumption of events, this message-driven principle, is a key to reactive programming, and reactive programming supports reactive systems. So that answered why I should care about reactive programming. It could make my systems more reactive. So that's very high level. Reactive programming is all about asynchronous, non-blocking, message passing, event consumption, what have you. But again, if you're like me, I glaze over when people say buzzwords like that and they're just telling me, read this paper. I need concrete examples and actual concrete problems. So I came up with one. In this problem, we're going to have a database of users or conference registrations like you all. This database is something that we have a few systems downstream would like to consume events from. They want to be notified anytime a user registers for the conference or anytime they sign in for the conference. They want to be able to know the metrics of how many users actually showed up or were absent. We also don't want those downstream systems to poll us. They don't want to constantly check, okay, how many users you have now? How many do you have now? They want us to push data to them. One other caveat is we have little to no control over the database, meaning if you're familiar with Postgres and some SQL databases, you have event triggers. So anytime something enters a table, you can use an event trigger and be notified that way. We have read-only access to the database, no event triggers to be made aware of. So that's a limitation. We ourselves also don't want to continue to poll the database if no one wants these events. We don't want to keep polling for 2 weeks at a time when no one is interested in those 2 weeks worth of events. So that is our problem. And to think about our problem, I have some terms that we should go over first. The first two are hopefully kind of familiar to you. If you're aware with Kafka, PubSub, you've probably heard of publisher and subscriber. On a high level, a publisher is someone or something that publishes an event or an object, and a subscriber listens for those events or those objects. With Reactor Core, which is the API within Java that we'll be talking about more, publisher is actually an interface. Flux, that made up word I was talking about earlier, implements the publisher interface. A Flux is basically a publisher of asynchronous objects or events, more than one object or event. Mono is also a publisher, but it's only 0 or 1 events. I'm honestly still not sure why they had to do it that way. Just know there's a difference. Mono, you may have no events or you may have 1 event. For Flux, you have at least 1, anywhere up to n. The last one is operator. This is a method, function, what have you, to do some piece of logic or behavior on your publishers. And if you want, these are actually the terms that I just went over. One of those people, I hate having a lot of text on the slides. These are some of the key terms that you'll see me mention. I'll mention flux and operator quite a bit, and I'll also add a few more key terms later on as well. And if you're interested, the code that I'm going over and the slides will be on my GitHub by the end of this conference. Or maybe next week. We have a couple parties tonight and tomorrow, so we'll see how that goes. All right, so this diagram. This diagram will help us talk about the order of events and kind of how publishers and Fluxes are going to work. In our example of conference registrations, we have a timeline at the top, starting at, say, 11 a.m. And from left to right, this is the timeline moving on from 11 a.m. all the way to 11:18. This green circle is a flux. I am generating a flux of long values, 0. I am passing that 0 in my flux down to the operator and mapping that to an instant representing 11:02. As time goes on, my first flux at the top, the circles, emit another event, gets passed to the operator, and that spits out another event to my second flux for 11:04. This is what the flux diagram would look like if 18 minutes have passed. I wanted to illustrate that this isn't the final view of the flux. We're not spitting out all 8 events in one moment. It's incremental every 2 minutes because of the intervals that I'm generating in the top. Now, once I have my bottom flux here of instants, I want to do something else with those. I actually want to take that instant value, use that, query my database to find users that were created since that time or updated since that time. And I now split that into 2 different fluxes. On the left, flux number 1, are my guests or my users that were created after 11:02, 11:08, and 11:14. On my right is flux number 2, where I updated my user after 11:10 and 11:16. Now, that is great information to have, but I actually want all of this information to be in one flux in one stream of data. I can now pass these 2 fluxes through another operator called Concat Map. What this does is it concatenates the 2 fluxes together, but it also does something else that's important to me, and that is reordering everything. So flux 1 has my creates, flux 2 has my updates, but the order of some of those events look a little swapped. Once I concatenate them, the order is corrected. So I have 2 creates, an update, a create, and an update. So now I have my flux of events that I can pass to another subscriber or user and say, these are the users that were updated or created in this time. Once I have this flux of triangles at the bottom, I pass it to yet another operator called publish. So what publish does is it actually shares my flux with the ability to have multiple subscribers listen to these events. One key thing here is I'm changing from a flux to a connectable flux. The operators on connectable flux will, of course, be different. The behavior will be different. One of those operators on the connectable flux, which is at the top, is called ref count. Ref count will allow me to control the fact that I only want at least 1 subscriber. And if at any point in time I don't have any subscribers, kill the connection. I'm not going to continue sending events. So once I have my connectable flux and I send that through ref count, here's an example of a subscriber on the left with the blue arrow pointing up. So I have a subscriber saying, hey, I'm interested in events now. Well, a user was created at 11:03. The subscriber gets that event. A second subscriber comes on. Both subscribers get the second event of when a user was created at 11:09. My first subscriber cancels. Of course, they don't get that event, but my second subscriber still does. My second subscriber cancels, but it's within a grace period that I can pass into ref count. So I'm still generating events because I'm waiting for at least one other subscriber within a grace period. Let's say it's 30 minutes, a minute, 30 seconds, whatever that grace period is. So my publisher is waiting around, is still generating events. Within that grace period, I get a third subscriber, and then that subscriber gets the next event. So that's what ref count does. It takes a second to really wrap your head around it, but it allows me to keep the connection alive for my publisher, no matter the number of subscribers I have, but I also don't want to keep pushing events if I don't have any subscribers. So all those diagrams I showed you are my loose interpretation of the marble diagrams that Reactor uses in their documentation and their reference guide. This link for how to read marbles is very useful, and the reference guide is extremely useful to try and understand some of what the operators are doing. And their Java doc is actually pretty good as well, and their Java doc includes these marble diagrams. All right, time to dive into some code. Everyone can see that okay? Perfect. So I have a very rinky-dinky Spring Boot app with Java. I'm using JPA and Lombok, and it's backed by an embedded database with the H2 library. In here, I have my guest entity for my database. I have first name, last name, the guest ID, and the guest status, whether they were registered, if they canceled the registration, if they were absent, what have you. What I want to happen is to map those objects from my database into the objects that downstream systems want to consume. And it's a pretty simple one called registrant change. So they just want to know the guest ID and what status they're now in. Was this person created, deleted, or updated in some way? And this is the guest status enum. So I have a controller. Like I said, this is a Spring Boot app. So I just threw together a simple controller that has a create, update, and post endpoint to manage my guests. One other thing is that I have this subscribe here to mimic a subscriber, one of our downstream subscribers. On line 17, we'll talk about the event emitter in more detail. This event emitter is actually a publisher, and this publisher or component actually has a changes method that I can then subscribe to. This log is very helpful, and I'll point out what the log looks like, but this is very helpful for debugging and trying to understand what Reactive is doing and when. It will actually tell you when a subscriber was made, what event was next, when a cancel happened, error, all of that. It's just not too pretty, but if you want, you can look into having using a different logger to make it a little easier to understand. So our event emitter, wonderful name, right, is a component, and it has a changes variable called that is a flux of registrant changes. So this is what my component is responsible for making, and that's what our controller is subscribing to. So let's talk about how we make those changes. On line 20, I am first doing flux interval duration of minutes 1. So if we go back to our diagram here, I'm basically doing this top part up here. I am saying every minute spit out a long value. On line 21, I'm using my map, which takes in a function, and I'm taking this long value and doing absolutely nothing with it. I'm cheating a little bit. Usually, you want to do something with the thing that's being passed in, but this is a bit of a cheat because I just want an event to be emitted every minute, and this is a way that I can make that happen. I'm just going to throw away that long and just generate an instant of the past minute. On line 22, I want to use the Concat Map. And if you remember, the Concat Map allows me to combine, allows me to combine two different fluxes. This load changes method creates those two fluxes using the load updates and load creates method and concatenates them. In these methods is where the real work is being done. On line 33, I create a flux from my database query. So that instant that I had before, I'm naming after, and I'm saying, find me all guests that were updated after this specific point in time. I create a stream from that, I map it so that I can translate my guest object to the registrant object, and I return that flux. That's all that I'm doing, and that basically represents the right side. Same exact thing is happening in load creates. I am creating a stream of events from the database, but for users that were created after a period of time. I'm mapping them from my guest object to my registrant object, and I am returning that to be concatenated later. Actually, I lied. These two methods aren't doing the exact same thing. There's actually a very slight difference, and you can kind of see it in the spacing between the two methods. Can anyone tell the difference? It's very hard. Okay. This is one of those things that tripped me up, so hopefully it won't trip you up. In updates, you will notice that my entire parameter from stream, where I'm creating a flux from a stream, my entire parameter is from lines 33 to 36. So I'm getting a stream from the database, and I'm still doing the mapping. For my load creates, my parameter is only from line 41 to 42. The reason being, map is an overused word in the Java language. The Reactor Core has map, stream has map. So in my load updates, I am using, oh, come on, IntelliJ, the stream API with the map. With Reactor, I'm using the flux map operator. I cannot tell you the number of times I've tried to figure out why isn't this operation coming up, and it's because I am in a stream or I am in Reactor Core and I have to remember that I'm dealing with two different APIs, and there are other operations that are similar as well. So that's certainly one of those things that makes debugging or working with Reactor Core a little tricky. And depending on how, this is not a complicated example, but if you're doing something very complicated, that can get messy and annoying real quick. Yes. Yes, you can use them interchangeably. So depending on what you are doing, the behavior can change. And depending on the API that you're using. But for now, with this example, because I'm not doing anything extravagant or complicated, they're doing the exact same thing. But as with everything, whatever Reactor Core map is doing may be different from what stream map is doing. So there may be a difference in performance, or there may be some other difference that you just don't know about until you get into some really tricky production problems. All right. Okay. So I already have my application running, and let me bring up my console here. In Postman, I'm first going to subscribe to my publisher. And at the bottom here, you can see where I have unsubscribe and request. Doesn't really mean much. This just indicates that my publisher got a subscription or got a subscriber. I am going to create a user. I created the user at 3:45:58. And if you remember, I am pulling the database every minute. I started my subscription at 11:45:36. Oh, I must be in, different time zone. 11:45:36. So at 46:36, and hopefully this works and doesn't make me a liar, we'll actually see two events happen. We'll see a create and update event be emitted for our subscription. Oh, and there we go. Yay! Didn't make me a liar. So this onNext basically shows what event was pushed out to our subscriber. We got a created one and an updated one. The reason we get two is because both my created at and updated at times on my guest object are exactly the same. Now, if I go and do an update, where I say the guest was checked in, and my updated ad is now 11:46:59. At about a minute from now, we'll see another event. One other term, or two other terms, I want to introduce is hot and cold publisher. This is an example of a hot publisher. And what that means is anytime a new subscriber comes on, let's say this was actually deployed somewhere and one of y'all subscribed to the publisher, you're not going to get the first two events. You're only going to get this third event. So a hot publisher doesn't allow a subscriber to see from the beginning of events, but a cold publisher does. So here's a helpful diagram, because I'm a very visual learner, and with something like this, the more complex it gets, the harder it is to really understand what's going on. So the marble diagrams and drawing it out is extremely helpful. With this hot publisher, with my first subscriber, I get the very first event. With my second subscriber, I get only the second event. Remember, I mentioned ref count before with the grace period. If at any point in time I drop all of my subscribers and I get another subscriber still within that grace period, that subscriber is only going to get my fourth event in this example. Oops. Now, let's say the grace period had passed after I had dropped some subscribers and a new subscriber came on. That is just going to start my subscription all over again. So that's why the grace period is actually a pretty important thing to keep in mind if you have one, because that behavior of what a subscriber is going to see is going to be different. For a cold publisher, with every subscription, they basically get the beginning of that subscription. Now, the thing that makes cold and hot publishers confusing is you can make a hot publisher a cold publisher, and you can make a cold publisher a hot publisher by any number of ways. The way that we did it in our example, that interval, the flux interval command that I made, is actually a cold publisher. Is like this. But by using the publish and ref count, I turned it into a hot publisher. I can also turn that hot publisher back into a cold publisher by using an operation called cache. There's a lot of different ways to do a lot of these things, and that adds to the confusion. And understanding the difference between a hot publisher and cold publisher, especially going through the documentation, is extremely helpful. All right, final thoughts. How am I doing on time? Perfect. I've learned a lot in dealing with reactive. So I'll leave you with some of these key takeaways before we get to questions, and hopefully y'all have some, or we could just break for lunch. Reactive can do a lot for you. It can be very helpful in very specific situations, but with a caveat. I realized that there's a lot to learn and still a lot to understand. A great example, I don't know if y'all noticed this, but IntelliJ is giving me a warning about the find by updated and find by created. That is because this is actually a blocking call that I'm trying to make inside a non-blocking context. It works with this example. It's fine. It compiles, it runs. However, it could lead to thread starvation depending on the data that I'm dealing with, depending on the resources that I have. This could eventually get me in trouble if I push this into production. So even that, having to now figure out, okay, how can I rewrite this so I'm not dealing with thread starvation? How can I turn a blocking call into one that IntelliJ won't warn me about, and into one that's not going to cause thread starvation? There's so much to learn about Reactor Core, and I still know a lot of people who are very well versed in it and still get caught into some issues of, well, I did not know Reactor had that specific behavior because of that one thing we did not configure properly. The other thing I learned is that Reactor Core can bite you in the butt. Like that previous example, there are some times like where you just see an issue, it pops up every so often, and you really have to debug where things are going wrong with Reactor Core. And because of all of the nested operators and because of all the different things that you can do with streams, it can be a little difficult to actually debug. You can't just drop a debug into a Lambda sometimes. Like you're gonna have to figure out how to really determine where the problem is. And I love Golden Girls, so I could not put this in here. This is perfect. The last thing that I learned is that I like reactive programming a lot. I actually plan on rewriting some of the code that I have using reactive programming. But I also hate it. I can't stand it. Like I said, it gives you a lot, but if you're not careful, it can cause more problems than good. And having a great community of reactive programmers and other people to consult has been extremely helpful because we're not alone in seeing some of those problems that you're probably going to run into at some point. So hopefully you have learned some of the good things about reactive programming. You have a better understanding of what it is, and hopefully you feel more encouraged to actually go out and try it with a very healthy dose of skepticism. Cool. That's all. So questions? Yes. So Spring Web Flux is actually one of the reasons I wanted to get into reactive programming a little bit more. With Spring, Web Client, I think in the next major release is going to be deprecated or something. Like soon, Web Client is going away, and I figured I really need to understand what Web Flux is. So I haven't used reactive programming with Web Flux just yet, but it is something. That's my next step. I wanted to understand reactive programming and what fluxes were and all of those terms before I tried to understand Web Flux.
And similarly with Java RX?
Java RX, I don't think I've used anything with Java RX. No. So someone had asked if I have an example with mono. I kind of do. I can get back to that. Where would I go for learning reactive programming? So the the project reactor.io website has a lot of resources on there. They have a lot of slides, they have recordings, they have tutorials, they have code examples that I went through for this presentation, as well as to try and understand more of what's going on. But their website has been pretty helpful. And like I said, their reference guide is like an addendum to their Java doc. So their Java doc is very cut and dry. This Flux operator does this thing, but the reference guide actually gives you some examples and some gotchas for some of the operators. Oh, that's a great question. Slide 16, are operators built into the reactive Java library, or can you make your own? So from what I have seen, all of the operators are built into the reactive Java library. Technically, you can make your own using functions. So there's certain operators that will allow you to transform a flux or create a flux from a stream in a specific way. And those operators take in a function. So you could just pass it your own method. But as far as I know, you're not able to make your own. What are some typical use cases that benefit from the reactive style? So the most natural use case is, again, this pipeline of events. So if you have Apache Kafka, there's actually a library between Kafka and Reactor Core, for instance, to use Reactor Core to consume messages from Kafka. It's a natural fit of you just have a slew of events, you don't know when they're going to come in, you may need to respect the order, and you want to transfer them, do some kind of operation on them. that is perfect for reactive programming, which is why I'm thinking about changing some of my imperative code into reactive programming, because I have some inventing behavior like that. What type of application would benefit the best from reactive programming? I would say a backend service communicating with the web service, but that's just biased because that's where, like in this example, when I mentioned those downstream services that want to be notified of different events from users, my thinking was that could be a UI. A UI developer is not going to want to ask our API repeatedly, do you have a new user now? Do you have a new user now? And they often want that information to be pushed to them. So GraphQL, for instance, has this feature with subscriptions. And if you're not familiar with GraphQL, GraphQL is like a query language for your API where you can, yeah, that's the best way I can put it. Within GraphQL, the UI can actually subscribe to updates and events from your backend. So I naturally see a backend application communicating with another web app or UI as a pretty easy example of where you can benefit from reactive programming. And of course, from backend to backend, if it's, again, dealing with eventing, that could be beneficial as well. In addition to being a publisher, can a Flux also be a subscriber, since Connectable Flux is subscribed to Flux? This reminds me of you know how you read something and it's very like, what does this even mean? Like, one thing can be, Flux can become a mono, mono can become a Flux, and just all of these words are everywhere. That's what this reminds me of. And I say that because this is a great question. I would not be surprised if there is a way to have a publisher be a subscriber. I don't think they would call it that in the documentation, but I do know there are operators on a publisher where you can pass it another publisher. Does that make sense? It's one of those things that I want to do another example of, but I think what you could do is, if in our Flux example, Flux of user events, I could add another operator and say, whenever this other publisher gives me events, combine that with the publisher that I have, or use some of those events from this other publisher within my publisher as well. That is Inception. That's the word I was thinking of. It's very much like Inception when I thought of that, of like, a publisher can become a subscriber and a subscriber can become a publisher. And is it at any point a form of recursion? That's how I feel sometimes looking at all of the reactive documentation, because it can be very Inception-like. Anyway, to answer that question, technically, no. Technically, there's not a publisher, subscribe, publisher kind of thing, but there is a way to pass a publisher into another publisher. I'm very curious of what that use case looks like and when you would do that. I will, do you have this code pushed out to GitHub? I will have this code pushed out to GitHub, and it's all over my website. Did I mention my website at all? CeciliReid.com or CeciliPool.com is my website. That has my GitHub link. My GitHub handle is creid31. So all of this code is actually already in my public repo there, and I'll have the presentation there as well. And I'm sure Devnexus always sends out an email after the conference where we have the option to send everyone links and code links and slides. Excuse me. All right, so technically we have 9 more minutes, so if anyone has any other questions to ask, please ask them. But hopefully the person who asked about an example with mono is still here, and I will go over that. Thank you. And a quick plug, if you are interested in reactive, the next session will hopefully build on this even more. All right, so Out of curiosity, is the person who asked about mono? Okay, thank you. I just want to be sure I'm not wasting anybody's time. So I said, technically I do. Same way that you can create a flux from a stream, you can also create a flux from like flux.just and then some kind of, value of data. You can do the same thing with mono, where I can just take a mono and say, create a mono out of this one object. You also have mono.empty. Now, one of the things that the reason I said I technically do have an example of mono is in my random code example here, what I wanted to do was explore this concept of nested fluxes. So on line 10, I create a flux from number 0 to 10,000. I'm mapping it to some other number because I was bored, why not? I'm then using this window to split that one flux into multiple fluxes of 10 different objects. So from 10,000 numbers, I now have 1,000 fluxes with 10 numbers. Now, what I wanted to do is see what happened. PQL, flux windows, yes. Yes. Reduce. What was it? I'm pretty sure it was Concat. Yeah. The difference was Concat Map is going to give me a flux of engineers, whereas Concat was engineers, a nested flux of integers, whereas Concat was actually going to give me a flux of monos. Basically, what I was trying to do was if I have numbers 0, 1, 2, 3, 4, 5, 6, so on, 10. I just wanted to add all of those numbers together and merge them back into just one flux. So I figured I could do that with the concat, but it wasn't giving me the behavior I wanted because it was turning it into mono. There are certain operations that will take a flux and turn it into a mono. So a good example would be, let me actually bring up some of the documentation here. All, I think it is. Yeah. So in this case, with all and any, I want to know if all of the objects in my flux, if they're all integers, that is going to spit out a mono. Basically, mono is just a way to represent an object in a non-blocking way. Because I'm within the non-blocking context with flux already, it's not sufficient for these things just to return Boolean. It has to return mono, because that's what we are subscribing to. If you remember, Fluxes are publishers. They implement the publisher interface. Mono is also a publisher implementing the publisher interface. So if I am doing some kind of action in all this non-blocking logic to create a publisher, I can't just go from a flux down to a Boolean. If I just want one object, I'm going to go from a flux to a mono. Does that make more sense? Cool. Any other questions? Any other examples? We can talk more about this for sure. Well, you got 4 minutes. Any other questions? Cecili Reid, 31. Cool. And let me, I'll just comment you out too. Does that solve it? Sweet. Guest controller. Now, and like I said, I'm not using WebFlux. I know there is, so if I was going to use a REST API for another application, I have the option of either using Web Client to communicate with that API now, or WebFlux. With WebFlux, I would be able to consume all of the objects in a Flux object. What I want to figure out is how do I turn my controller into a publisher because that's really where the benefit is. Like if I'm communicating with a regular Spring application and it's truly blocking, like you're not going to give me a list of users until you're done. If I'm using Web Client to consume from that, it's not going to be much of a difference. It's just, instead of having, if my API originally returned 1,000 users, it's not paginated, all I have is 1,000 users, and I block to get those 1,000 users, if someone else is consuming that as a WebFlux client, they're just going to get a flux of 1,000 objects. That latency and that blocking is still there. There is a way for me to say, I am now going to be a non-blocking server, and I'm going to send you users as I get them. So rather than block and wait until I get 1,000 users, I'm just going to open up a connection and start publishing these users. So the client on the other side using WebFlux will just start being able to consume those events rather than 1,000 at a time. That's what I want to get into a little bit more. The other way around. So like if I'm consuming as a WebFlux client, the benefit would really come from if that other server is sending me non-blocking events. If they're sending me blocking events, then I don't get that latency benefit, is what I'm saying. So as a server, I want to understand how can I do that? Because all I know is like with Spring like this, like what does it look like? Is it something as simple as I now just turn this into mono and that's it? Yeah. Yeah. No, you're fine. So in here, it doesn't necessarily tell me this log operator has other configurations. Like I can change my logger, but I can also say like what information I am logging out. So in this just basic example, just telling Reactor Core, just log whatever you get. This on next is what the subscriber is seeing, or what the subscriber is receiving. Cool. And leave feedback too, please, because there are apparently awards now for speakers, so I'm curious what that looks like. But I also want your feedback. As you do the feedback on the schedule, and if you go to the actual session, at the bottom, there's a comment box and some stars. So if you haven't been rating your talks, please go and do that. I'm sorry? Okay. Thank you, everyone. It's time for lunch.